This is a picture of a DNA replication bubble. There's the two strands of DNA. There's a bubble. The DNA strands run anti-parallel to each other. Here's the 5 end, 3 end, and the other one is the 3 end and the 5 end. So DNA helicase unwinds the DNA to a bubble. And topoisomerase keeps the DNA from being too unwound. DNA replication starts at the origin of replication. And DNA replication is started off by primers, RNA primers. Primers are made by primase. And then nucleotides are added by DNA polymerase 3. This is the leading strand of this strand. And it runs from 5 end to the 3 end. And on the other side, same thing. Primers made by primase, DNA polymerase 3 adds nucleotides from the 5 end to the 3 end. Leading strand for this strand. Then there's the lagging strand, and it's the same thing. Primers, nucleotides added by DNA polymerase 3 from the 5 end to the 3 end. And on the other side, primers, nucleotides added, 3 end, 5 end. Then once all the nucleotides have been added, once all the DNA has been replicated, again, they run anti-parallel. So from 5 to 3, they're added this way. That's 5 end, it's 3 end. It's the same thing on the other side. So after all the DNA has been replicated, then these RNA primers are turned into DNA by DNA polymerase 1. And then these fragments of RNA that used to be, these fragments of DNA that used to be RNA are called Okazaki fragments. And then after that, another enzyme called ligase binds these two strands together. So this has become DNA. This is DNA. These are Okazaki fragments. They're all binded together by ligase. The DNA polymerase 3 first added the nucleotides. The DNA polymerase 1 turned the RNA primers, the RNA, into DNA. They became Okazaki fragments. And then ligase binds them together. So there you have it. DNA replication. The end.